Yo, 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 this is Mr. O. Morning guys, today we're gonna go over with loss of exponent, but before we go there, let me try to help you with simplifying basic involvement exponent here. When you have 2 to the 1, let me go here first. When you have 2 to the 3rd power, 2 is your base and 3 is your exponent. The meaning of the exponent there, you will multiply the base by the number of times of the exponent. So if I ask you to expand this, the meaning of that one is 2 low battery. 2 times 2 times 2. I'm multiplying the base 3 times because the exponent is 3. And the answer here is 2 times 2 is 4 times 2 for the 3rd time. Can't do it. 8. Make sense? Okay. So when we go here, 2 to the 1, how many times, if you multiply 2 to itself, it's just going to be 2. You guys, you can respond, okay? What's 2 squared? 2 times 2? 4. To the 3rd, we just did it. The answer is 8, not 6. What's 2 to the 4th? 2 times 2 times 2, 8 already. Times 2 for the 4th time, it's 16. 3 to the 1, it's going to be 3. 3 to the 2nd, not 6. 3 times 3 is going to be 9. 3 times 3 times 3, if the previous one is 9, times 3 will be 27. And times 3 again will be 81. 4 to the 1 is 4. You multiply it by the 4th for the 2nd time will be 16. So the 3rd one will be 64. And for the 4th one, it's
256.
5 to the 1st power is 5. 5 to the 2nd, 5 times 5, it's 25. 5 to the 3rd is not 15. 5 times 5 is 25. Times 5 again, it's 125. Am I right, guys?
Yep.
6. 6 to the 1 is 6. 6 squared. 6 times 6 is?
36.
6 times 6 times 6 will give you?
216.
Give it to Jennifer, please. 216. William. 7 to the 1 is 7. 7 squared is 49. And 243?
343.
343. Thank you. These are the simple items that I expect you at least to, not to memorize, but be familiarized with these numbers. Why? You will see this a lot on this chapter, okay? So make sure that you have received the foldable. These are we're gonna go over with the rules and laws of exponent. I'm sure most of you have seen this before when you were in middle school in Algebra 1. We're gonna go over it. And once we have strengthened our foundation, then we're gonna go a little up notch to the laws of exponent. Okay, so there are 6 that we're gonna learn today: the quotient property, the negative exponent, zero exponent, power of a product, power of a power, and product of property. And we're gonna go over to each of them. Okay, the first one here is the product property. Means you're multiplying the x to the m by x to the n. Your multiplication here, multiplying. When you're multiplying, if you notice, they have the same bases. They need to have the same base. And the exponent are m and n. They could be the same, they could be different. What do you do with m and n? You add them, m plus n. And that's the rule there. So you copy the base, but you add the exponent. So let's see the example here. Number 1, x to the 5th times x to the 7th. The bases are the same, they're both x's. The exponents are 5 and 7. So what do you do according to the rule? You add the 5 and the 7. What's 5 plus 7? The answer is 12. So the answer is 12 there. What's the logic behind the rule? Let me teach you some logic here. I don't want to just give you the rule here. What's the reason why you're adding them? Let me ask you, how many x's do you have on the x to the 5? There are 5 x's. Do you agree? And how many x's do you have right here? 7. 1, 2, 3, 4, 4, 5, 6, 7. If you multiply them, how many x's are listed here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's why it's 12 over there. That's the reason behind it. Okay? But obviously, I'm not going to ask you to write it, list them down all the time. Let's just do the rule that you just have to add the exponent. G squared times G4 is going to be G to the, copy the base, and 6. D times D8. What's the imaginary exponent of this D here? 1. So what's the answer?
D9.
D9. Kaboom. The next rule here is the power of a power. For this one here, there's a power, there's an exponent, and there's a power. How many base do you see here? You only see one x, one base right here. Okay. The idea is there's an exponent outside the parentheses, and what you do with m and n here is you just simply multiply them. Okay. So x squared to the third power, the answer here will be x. 2 times 3 is 6. What's the logic behind this? Let me show you. Let me do some teaching here. The meaning of that one, you have x squared 3 times. Why 3 times? Because the power outside is 3. So there should be 3 of them. And what does the product property tells us? What do you do with the 2's? You add them. 2 plus 2 plus 2 will give you 6. And that's why the answer is x to the 6. F7 to the 4th. But obviously, we're not going to list them down all the time. We're going to use the rule here by multiplying the exponent. F to the 7 to the 4th power. So you need to have 4 F7. So you multiply 7 and 4. That gives you F to the 28. C to the 5th power. C to the 5th power with a squared outside. That means you multiply 5 and 2. That gives you C to the 10. Next, product of a power rule here. This is simple. Here you just have to distribute. Remember, if there's no exponent, that means it's equal to 1. So there's a 1 here and there's a 1 there. What you need to do is just multiply the 5 to the 1 and to the 1 there. And then if you multiply the exponent to the 1, the answer is always itself. So basically just distribute it. So this will become x to the m, y to the m. So for this case here, you distribute the 3, x to the 3rd, y to the 3rd, j to the 5th power, k to the 5th power, r to the 8th, s to the 8th. If I try to make it a little complex than this one here, example number 4, if I make it, let's say, a squared, b cubed, and c, let's say I put here to the 4th power. What will be the answer for this one here? Think. Pause it and try to answer it. Now, what you do is that you multiply 4 to the 2, 4 to the 3, and what's the imaginary or invisible exponent of c? 1. You multiply 4 to the 1 there. That makes it a to the 2 times 4 will give you 8. 3 times 4 is b to the 12. And 1 times 4 is c to the 4. And that's the answer. Excuse me. Next rule is the quotient rule. Quotient rule for dividing. Okay? When you're dividing, make sure that your exponent or the bases are the same. What are the base here? The base here is x, the base here is x also. You can only apply the quotient rule if they have the same base. A while ago, when we multiply, what did we do with the exponent? We added them. What if we divide them? What do you think will you do with the m and the n exponent? You will subtract. It's the opposite. So here, x, m minus n. Assuming that m must be bigger than n. We will go that later on. Okay? Make sure that the exponent of the base of the numerator should be bigger. Okay? Because there's a strategy on how to analyze or simplify our final answer with that, which we will go through later on. Okay? So anyway, so number 1, x to the 7 divided by x to the 3rd power. Again, for this case, if you notice all the example here, the numerator has bigger exponent. X to 7 divided by x3, the answer is x to the 7 minus 3 will give you 4. Let me explain some logic, the reasoning skill behind this. Why? How many x's do we have here? How many? 1, 2, 3, 4, 5, 6, 7. How many x's do we have in the bottom? 3. So 1, 2, 3. What's x divided by x? Remember, we cancel it out. We cancel this. We cancel this. How many x's are left? 4. And what's the answer here? X4. That's the logic behind it. Okay? Same thing with this, but obviously I'm not going to ask you to write them down all the time. Just use your rule that you subtract the exponent. 8 minus 5? 3. 9 minus 3? 6. Let me show you something that, what if Mr. O, the exponent of the denominator is bigger than the numerator? Example number 4. Let's say A4. Let's say A9. Okay, think about this one here. Here's how we're going to solve it. How many A's do we have on top? 4. How many A's do we have on the bottom? 6, 7, 8, 9, right? What do we do? Cancel, 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 cancel. Do we still have A above on the numerator? We don't have an A anymore right here on top. But do we still have A on the bottom? No. How many? 1, 2, 3, 4, 5. So the answer now here, is the answer A5? No, it has to be 1 over A5. Why do you think so? First, who's bigger, 4 or 9? 9. We still subtract them, but we always subtract it from the bigger number. The bigger number is 9. So 9 minus 4 will give you 5. But where is the bigger number? Where's the bigger exponent? Top or bottom? Bottom. That's why the answer has to be in the bottom. Make sense? If you don't see that one, try to list them down like what I did here to show where you're going to put the answer. There's a negative property here that you cannot have a negative exponent. You have to simplify it, which we're going to go later on. Okay? Next. Here's the negative I was telling you. If you have a negative exponent, you cannot set that that's your final answer. You have to simplify it. So what do? You know that there's an imaginary one here, right? To make the exponent positive, you have to switch its position. Means that you have to bring it down to make it positive. So this becomes 1 over x to the m. So if I have x to the negative 4, that becomes 1 over x positive 4. If I have n to the negative 2, that becomes 1 over n squared. If I have a to the negative 7, that goes 1 over 8 to the positive 7 there. A challenging problem will be like this. Watch me here. 4 and 5. If I have 2x to the negative 3, is this a simplified form? No, we cannot have a negative exponent. So what do? This portion here in green has to go down. So the answer here is 2 over x to the positive 3. Mr. O, why is the 2 spaced on top? Why is it not with the x? Because what is the exponent of 2? There's an imaginary one there, remember? Is that one positive or negative? That's positive. So that 2 remains where it is. Only the one with only the base with the negative has to go down. Are we clear? Or does it has to always go down? No. What if I have here 3x negative 2? The x is negative there. The negative of the exponent of x here is negative, and you cannot go down another notch there. What you need to do is to go up. So if you bring this up, the negative 2 becomes positive, so it becomes 3x squared. Mr. O, why the 3 did not go down? Because the 3 has a positive, so it stays where it is. So that's the answer for that. Last one here, the zero rule. The zero rule here, zero power rule. This is the simplest one here. Any base that has an exponent of 0 is always going to be equal to 1. Okay? Anything that has raised to 0 is equal to 1, except 0 to 0, okay? 0 to 0 is still undefined, okay? X to the 0 is equal to 1, x to the 0 is 1, f to the 0 is 1, w to the 0 is 1. Here are the challenging question. What if 2x to the 0, what's the answer, guys? Remember, x to the 0 is 1. What's the exponent of 2? The exponent of 2 is not 0. The exponent of 2 is 1. So what's the answer here? 2. Good job. Number 5. What if I put 2x to the 0? Both of them are under the exponent of 0. So the answer here will be 1. What if I put here LeBron James to the 0 is equal to 1? Okay with that one? I hope you learned the 6 rules or laws of exponent, and we'll discuss it more. Kaboom!